Now let's proceed. Now let's look at this exercise here. Okay, this is the last thing we are going to do, but I think you can also try and then just answer them if you can, but you will try to answer that here. I will just do this. We are going to answer them all here. So I have the sequence. It says consider a DNA sequence this. How many nucleotides are present? Okay, so let's start with question number 1. We have how many nucleotides are present, calculate GC, percentage GC, how many purines, pyrimidines, calculate percentage of purines, etc. So we are going to take a look at these questions one by one. I think it's going to be very helpful. So question 1, how many nucleotides are present? Before we even do that, we need to what? First create this sequence. It's a string. So that means we have to create the sequence. Okay, so let's say DNA. Let's use this. So I have that created. So now I can answer. So question 1, let me check. Question 1 is how many nucleotides are present? So in other words, we are looking at the length of the sequence. So if you want the length, then it's what? Learn what? DNA. Simple. Then we get our answer. So we have what? 23 nucleotides. That's what we have here, basically. Now let's look at question 2. Calculate the percentage GC. So how do you do it? First, you need to get a GC content. So that means it was GC is equals to what? DNA.counts gene plus what? DNA.counts C. And then you also need to get the length, which is what? Len DNA, which I've already covered. And then percentage GC. GC is equals to what? GC over length times 100. So now you can print your GC, percentage GC. You have it here. Okay. Now we can convert, or we can change the we can change the decimal places. If let's say you want 2 decimal places, then you can just say percentage GC equals round percentage GC, and then to let's say you want 2 decimal places. So now I can print it, and then I'll have my answer. So I have 52.17. Okay, let's look at question number 3. How many purines are present? Purines are A's and then G's. So get the purines is equals to what? DNA.count A plus what? DNA.count gene. Yeah, let me make it a bit description. Say number of purines. So now I can print this number of purines. It's 15. Question number 4, how many pyrimidines? So it's the same principle here. Okay, by this time we change. Let me just do it again. So I'll say number of pyrimidines. So that'll be what? DNA.count. And that'll be what? C plus DNA.count T. We have C and T. So now I can print its number of pyrimidines. So I have 8. So this was for question number 4. Now let's look at question number 5. Question number 5 is calculate the percentage of purines in the sequence. So if you want purines, I already have that here. I will just copy this code here. So if it's percentage of purines, I need to get my number of purines. I need to get my length, which I've already done here. I'll just do a copy and paste here. And then when I come to percentage of purines, then it becomes what? Number of purines over length star 100. That's times. For these mathematical operations, I'm going to cover them in another tutorial. So for now, I'm just giving them bits. I'm giving them to you in bits. Okay, so I have this. So now I can print percentage of purines. Okay, so I have that here. Again, you can change it to 2 decimal places. So this one, I'll leave it to you. So that's your assignment. Number 6, question number 6. Which nucleotide is in the 10th position? So nucleotide in the 10th position is going to be what? Let's just say, let's just use this. Nucleotide number 10 is going to be what? DNA 9, because counting starts from 0. So I can print it. So that's gene. So you can count. You can just count them manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's gene. But of course, indexing will start from 0. So it's what? 9. Let's look at question number 7. Write the sequences that are present in position 3 to position 9. So here we are looking at a range. Okay, so nucleotides, what's position 3 to 9 will be equals to what? DNA 2. Because we're looking at positions 3 to 9, or the 3rd nucleotide to the 9th nucleotide. Let me just put it that way. So 2 to 9. So why are we saying 9? Because we want the 3rd nucleotide to the 9th nucleotide. Okay, so the 9th nucleotide will have an index of 8, but we have to add +1 so that we get that value itself. That's why we are adding this. Anyway, you can always experiment. Some of these things, it may sound confusing, but then when you practice, when you repeat them, you do it, you make mistakes, you repeat, then you start to get a hang of things. So just make sure to practice, and then when you do it for some time, you understand why some of these things are there. And some of them are rules. I can't change them. So these are the rules that were set by the creators or the creator of Python. So you just have to follow. It's just like learn a language. There are rules. So you just have to follow the rule and then you'll be fine. So let's run this. I'll print nucleotides 3, 9. So I should have the answer here. Now let's look at question number 8. What command will you use to find which nucleotides are present from position 10 to 20? What command will you use to find? So it's basically the same thing here. Okay, the same thing I've done here. So this time I will just copy and then I'll modify the code here to give me 10 to 20. So let's see. So 10 to 20, that'll be what? 9. Okay, let me use the actual value here. But when you come here, it becomes 9 for this. So now I can print it. I'll just print that here. Okay, so that's what we have here. So this is what's 9 to 20. So this 20 here will not be included, but we have up to 19, and 19 is the hot 20th position. Okay, so let's go. Now we are going to question number 9. Does the DNA sequence contain GGAG? Question number 9. So we have to look for this. So how do we do this? Let's see. So we have to just query. I can just do this in DNA, and it's true. Okay, it's there. But if it's there, then how do we locate it? So then I can use what? Let me just add that here. I can just say, let me use a print statement here first. I can say DNA.find to locate where it starts. Yeah, let me use a print statement so that everything will be displayed. So 9, it starts from index 9. So let's check. Index 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's gene. That's what we have here. Okay. So if you want the exact range, then you have to use regular expressions to do this. But this is something that I'll cover in order to write. It will be a detailed video. So for now, I'll skip it. Question number 10. What do we have? How many times does TTA occur? So you can say DNA.count TTA 2 times. Okay. Please take note that this particular approach sometimes too may not be appropriate. Okay. There are situations where you have, let's say you have TTA, you can also have other nucleotides, making it a bit complex. And so there are better ways to count. Okay, you can use regular expressions, or if this were to be a list data type, then of course this one will work for all situations. But for the string data type, this approach sometimes may not work. Okay, so just take note of that. But of course, that's why you are learning, so you can just build on whatever you've been taught today. Let's look at question number 11. At which index does GTA begin? That's question number 11. So, of course, here we can use the find to do that. So I can just say DNA.find. And then I'll just paste it. So I have 1. Okay, index 1. Let's see. Let's check. 0, 1. We are looking for GTTA. Let's check. Yeah, so we have index 1. But here, what you should note is that if GTT occurs more than 1, okay, if you have, let's say, 2 or more of the GTTs, then this approach may not work. That's why I recommend that you use regular expressions. Okay, in some situations, the find and the count command may not work appropriately. So you just have to look at the situation and look at the appropriate method that can be used. But regular expressions, that one, I mean, you are sure of getting the right result when it comes to the find command. Now let's look at the last question. That's question number 12. Does the sequence contain the character Z? Of course, this is simple. So you see what? Z in what DNA is false. Okay. So here, we have DNA sequence, we have protein sequences. So for DNA sequences, we should have A, C, G, T. If you are dealing with RNA, then you also are expecting to find U. Okay. But if you see any other character like we have Z, then that means that it's invalid. It's an invalid sequence. Okay. So I mean, you can also use this to check if there are characters in your sequence which are not supposed to be there. So that's how we do it. Okay. So this is it for this tutorial. And then just make sure to check the description box. You'll find the link that you can use to download this notebook, as well as other bioinformatics tutorials that I make. So just to the description box and then get all that information. So if you also have any other comments, if there are things that you think should have been added, then you can just put them in the comment section, and then you can all discuss and then learn something new. So that'll be all for this tutorial.